Hello, and this is Stylianos. I'm a physics teacher in Align, and in this video we'll try to solve the first question from the AP Electromagnetism exam from 2023. Let's proceed to the question. We'll try to solve it as fast as we can, where we see a positive charge Q1 and another charge capital Q on another sphere that it is suspended from a string, and because of the electromagnetic repulsion the string forms an angle theta to the right. Let's go quickly to our first question, which is on the following dot represent the forces that are applied on sphere 2. I understand that eventually the sphere 2 will be in equilibrium, so the forces that are applied is the electric force from the electric repulsion between the two charges, the tension on the rope, and the force of gravity, the weight downwards. So this is what we will try to do: a weight downwards, an electric force to the right, and a force of tension in the direction of the rope. And on part B, we need to prove that the relationship between the distance and the angle theta is what we see. In order to do that, apparently we have to work with a little bit of mechanics here, like we need to remember that the electric force is K Q1 Q2 over the distance to the power of 2. In this case, the electric force is K small q capital Q over the distance to the power of 2. The weight is equal to force of gravity. Let me try to write it here. Force of gravity, which is mass times g. And the tension, there is no formula for the tension, but unfortunately the tension forms an angle. Now, the defined angle is the angle with the vertical, so we'll try to define the components of the tension as tension x equals tension sine of the angle theta, and tension y is equal to tension cosine of the angle theta. A little bit careful again, the tension, the two components of the tension, tension x and tension y, are defined through the angle, through the given angle theta, that it is the angle with the vertical, so the sine and the cosine have to be reversed here. Now, since we have equilibrium, then the total force upwards, which is the tension y, has to be equal to the force of gravity, so m times g, and the total force to the left has to be equal to the total force to the right, that it is the electric force, which is k q over d squared. We'll mention somewhere that the F net is equal to 0, so the F net on the x-axis and the F net on the y-axis have to be also equal to 0. Now we get two relationships, and if we divide them, we bring that tension sine theta over tension cosine theta is equal k q over distance squared over mg. The tension is cancelled. Sine over cosine is tangent of theta, and if we solve for distance squared, basically first we'll say tangent of theta multiplied by distance squared multiplied by mg is equal k q, and if we solve for distance to the power of 2, we bring k q over mg tangent of theta with a root, and the k, we know that it is 1 over 4 pi epsilon 0, so root q over 4 pi epsilon 0 mg tangent of theta, which is the relationship that we need to prove. And after this, we need to find the expected value of the tension if we know the charge, the angle, and the distance. So we'll try to work with this rule. So we will bring it back, and we will say that the tension is unknown. The sine of 12 is equal 9 times 10 to the power of 9, q, which is 6 times 10 to the power of negative 8, and again 6 times 10 to the power of negative 8 for the capital Q, divided by the distance to the power of 2, which is 0.057 power of 2. for this we'll have to go to the calculator. You'll give me 1 minute. So 9 times 10 to the power of 9 multiplied by 6 times 6, it is 36 times 10 to the power of negative 16. And all of this divided by sine 12 degrees and 0.057 to the power of 2. This will bring approximately 0.0479, so 0.0. We need 4 significant digits, so 0.048 Newton. And we continue to part D, where we see a graph of distance to the power of 2 and 1 over tangent of theta. And the first part will be to draw the best fit line. So we'll take our ruler and we'll try to connect these points, but we need some points passing above this line and some points below the line, so approximately this is the best fit line. But most importantly, we need to figure a value for the magnetic permittivity of vacuum. So we'll go to one of the rules that we proved before. I believe that it will be the final rule that the distance is equal to root of QQ. Let me just write it one more time. The distance is equal root of Q times Q divided by 4 pi epsilon 0 multiplied by mg tan theta. And since we don't want the root, we will have distance to the power of 2. This is the givens. So we'll write it in the form distance to the power of 2 equals QQ over 4 pi mg multiplied by 1 over epsilon 0 multiplied by 1 over tangent of theta. So the value that we need will depend on the distance to the power of 2 and the 1 over tangent of theta, which we have graphed. So we'll need to divide them in order to figure out what is the slope. Our coefficient here, which is all these values are given, and the only thing that is unknown is the value of the electric permittivity. So first we're going to say that Q over 4 pi mg multiplied by 1 over epsilon 0 is equal to the slope, and we need to find this slope. In order to figure out the slope, we'll go to the graph and we'll carefully select any 2 points that belong on the line, and we can clearly see the values. Now, one of the points that I see is here. We can clearly see that the value here is exactly 2.5, and the value here is 0.0015. And we need one more point. Now, one point that I see is this point, where the value for the horizontal axis is 9, and the value for the vertical axis is 0.0065. So the slope is rise over run, 0.0065 minus 0.0015 divided by the run, which is 9 minus 2.5. It will give me a moment for this. 0.0065 minus 0.0015, and this divided by 6.5, where the slope is approximately 7.7 times 10 to the power of negative 4. So we get that this slope is equal to the value for the Q, and the Q is given actually 6 times 6, so 36 times 10 to the power of negative 16, divided by 4 pi, the m is given 0.050, and the g is 9.8, and the only thing that we don't know, it is the 1 over epsilon 0. Sorry for that. We need to be a little bit careful with our calculations. So first thing is we'll multiply the slope by 4 pi times 0.0050 times 9.8, and then we're going to divide by 36 times 10 to the power of negative 16, and we get 1 over epsilon 0 is equal to this, so we have to consider 1 over the answer. Now I must have made some error in my calculation, so it will give me some time to repeat, or maybe we have to be a little bit proper here. The slope is equal QQ over 4 pi mg epsilon and 1 over epsilon 0. Okay, so we will bring that 7.69 times 10 to the power of negative 4 equals 36 times 10 to the power of negative 16, and then divide by 4 pi times 0.0050 times 9.8. So this factor is 5.84, or actually 5.85 times 10 to the power of negative 15 multiplied by 1 over epsilon 0. Then we divide 7.69 times 10 to the power of negative 4, divide by the previous part, divide by the answer, so we bring 1.31 times 10 to the power of 11 is equal to 1 over epsilon 0, and then we flip, so we bring that the value of epsilon 0 is approximately 7.6 times 10 to the power of negative 12. Now, I certainly do not remember the units for the value of epsilon 0, but we can find it from the formula that we have formed, that the distance to the power of 2 is equal to Q over 4 pi mg and 1 over epsilon 0. So we bring the epsilon 0 on the top, and we have Q over 4 pi mg multiplied by distance to the power of 2. Now, the charges are Coulomb to the power of 2, mass is kilogram. Actually, I'm not going to say mass times g, I'm going to say mass times g is a force, so Newton, and the distance to the power of 2, so Newton times meter to the power of 2. So we go back and we say Coulomb to the power of 2 over Newton times meter to the power of 2. And we continue to a new modified experiment where now we replace the first sphere with another sphere that has the same charge, and it is a conductor. I believe that the previous part was talking about a non-conducting sphere. And we need to state where there is an excess positive charge. Now, what changes between the previous part and the new part is that the charges on the conductor are able to move. Now, we consider that the positive charge has the ability to move, and because both spheres are positive, there is a repulsive force. So the positive charge on the first sphere will tend to be repelled to the opposite side, to the left. If we need a proper explanation, we need to consider that the negative charge is attracted to the right, and this will cause an excess positive charge on the left side of the sphere 1. Well, it is not sphere 1 anymore, it is in reality sphere 3. So we'll say that there is an excess positive charge on the left side of sphere 3 because on the conducting sphere 3, the electrons are attracted to the right. Actually, they are moved to the right by the electrostatic force. It's a little bit better to say that they are moved to the right due to an attractive force. So there will be excess positive charge on the left side. And in this new situation, actually in the original experiment, there was a distance 1 and an angle 1. If we keep the same distance, what is the new angle? Well, I don't really know what is the new angle. However, what this change will provide is that since these two positive charges are at a little bit slightly greater distance than before, okay, the distance between the balls is the same. However, the positive charge has moved a little bit to the left, so the distance between the charges is slightly more than before. More distance causes the force to be a little bit less, so since the repulsive force is a little bit smaller, this provides that the angle will be a little bit smaller as well. So this is what we will try to explain with a few words, that the angle, the new angle is smaller than before, since positive charge is on the left side. This increases the distance where the force is applied. And more distance will cause less force, and less force will produce a slightly smaller angle too. Now, this is the final answer for this part. I hope that you enjoyed the video. I hope that you learned something today. If you have any comment, please feel free to write it on the comments on the video. I hope you have a good day. Thank you.